Okay, hi all. So this is the solution guide to this question. 100 pound moles of a mixture of 20 mole percent ethanol, 80 mole percent water is charged to the still pot of a batch distillation column, equivalent to 3 equilibrium stages, excluding the still. So in total, there are 4 equilibrium stages, including the still. The distillation is operated at a constant reflux ratio of 3 and normal atmospheric pressure. From experimental measurements, the mole fraction of ethanol in the initial distillate and final distillate are 0.74 and 0.6 respectively, and the mole fraction of ethanol remaining in the still is 0.03. That's at the end of the distillation. So part A is to determine the quantity in pound mole and the average composition in mole fraction of the distillate. And part B, how would your answer be different if the process is stopped when the residual composition is 0.06 mole fraction ethanol? And you are given the VLE data for ethanol water at atmospheric pressure in mole percent of ethanol in liquid phase X of ethanol and mole percent of ethanol in vapor phase, i.e. the Y mole fraction of ethanol. Right, so you have a distillation column where you have 3 plates in the column and a still or a reboiler. So this is your reboiler. So you have 3 plates inside the column. So then your vapor phase is condensed and returned to the column as reflux, and some are withdrawn as a distillate D. So you started with 100 pound moles of liquid. So L1 is 100 pound moles. And XB1, initial XB is 0.20 because you started with 20% ethanol. And this column is operated at constant reflux ratio, constant R, where R equals to 3.0 and the pressure is 1 atm. So initial at T, let's say T equals to T1, you measure the XD, which is collected at the distillate product. XT1 you have 0.74, and after some time at the end of the distillation column, T equals to, let's say, T2, i.e. the final T, you have the distillate composition. When you measure the composition, you have 0.6, and the remaining composition of ethanol in the still, XB2, is 0.03. Okay, so these are the information given to you. And part A, you need to calculate what is the value of D and the average composition of ethanol, i.e. the XD average. Okay, so D, you would need to calculate L1 minus L2. You know L1 but you don't know L2. And also the average composition of ethanol, you need to find XD average. So we need to use the Rayleigh equation. So you can write down the Rayleigh equation in terms of XD and XB. So you started with ln L1 over L2 equals to integration of XD minus XB from XB2 to XB1. Okay, and the average composition of distillate, XD average, you can calculate using this using the material balance equation. L1 XB1 at the beginning of distillation process equal to L2 XB2 at the end of the distillation process plus what would have been collected in the distillate, L1 minus L2 times XD average. So if you can find L2, you can find L2 and you can find XD average. Right, so before we proceed to the solution, let's put up a strategy on how to solve part A. So, okay, let's say you have a steel with 4 equilibrium stages, including the steel. Then you are operating at constant R, and then you want to find the D, the amount of distillate. So you have to use this Rayleigh equation. Sorry, can I just rewrite the Rayleigh equation? So ln L1 over L2 equals to integration from xb2 to xb1 with respect to xb dxt minus xb. Okay, so you want to find L1 and L2, or actually L2 because you're given L1, so that you can find D, and in turn you can find the XD average. So let's say you plot the y versus x of the VLE for ethanol water at 1 atm. So it would look like something like this, okay, roughly. Then you have how many stages? Four stages. All right, so you are operating at constant reflux ratio, so your ROL equation holds. So your ROL equation is yn plus 1 equals to R over R plus 1 xn plus xd over R plus 1, and R is kept constant at 3, so your equation would look something like this: 3 over 4 xn plus xd over 4. So just take note that your xd is not constant. Xd is changing from time equals to 1 to time equals to t2, but your R over R plus 1, i.e. the gradient of the graph, is constant, and also this is constant, and also constant number of equilibrium stages in the column, because you can't really change the number of plates once you have set out with it. That's what you are given, so you have to work with it. So what you're gonna do is you plot the ROL, and then you step off at different values of xd, and then you will get different values of xb. Okay, so let's just try to write down what I'm saying. So xd, xb, and then you want to find out what is x1 over xd minus xb. Okay, you make a table like this. So you start with xd equals to 0.74 until at the end you want to stop with xd equals to 0.6, because that's what the question gives. At the end of the distillation process, the final distillate composition is 0.6. So you want to find out what is the value of xb when the xd is 0.74, when you plot the ROL and step off with 4 equilibrium stages. Okay, so your xd, okay, not that far maybe, because it's just 0.74, so it should be somewhere. Let's say this is 1, so this is 0.5, so let's say 0.74 is somewhere here maybe. So you can take, this is your xd, then you can find out when xd is 0.74, your ROL becomes like yn plus 1 equals to 3 over 4 xn plus 0.74 over 4, which gives you plus 0.185. So your y-intercept is somewhere around 0.185 here. So you can plot this graph, and then you step off 4 equilibrium stages, 3, 4, and then you find out what is the xb when xd is 0.74, and then you put that value here. And then you do the same for 0.6. Okay, so 0.6 maybe somewhere here. So 0.6 somewhere here. So you have a new xd, and you will have a new intercept. But since the ROL with constant reflux ratio, you will have constant gradient. The gradient does not change. So you just draw another parallel line crossing through the xd. Okay, you have to use your ruler, of course. Then you have this another ROL. This is ROL at xd equals to 0.6. Okay, if you step off this 4 times, then you should get the final xb. Okay, 0.03 or close to 0.03, because in the question it says at the final distillate composition it's 0.6 and the final bottoms composition is 0.03. You should get close to that. So we have 2 points, but in order to get more accurate result of calculation, you need to add another point, or you need to have at least 3 points, okay, to ascertain whether it's a curve or it's a straight line. So you put another xd here, at least one. So put, let's say, in the middle between 0.6 and 0.74. Let's say you put 0.66. Then you draw another operating line at the xd 0.66 and 0.66, and draw a parallel line. Okay, somewhere there. Then you step off also 4 times to get another xb when xd is 0.66. Okay, now that you have the value of xd and value of xb, 3 points, you can calculate what is 1 over xd minus xb. So you have 3 values, right? So you can guess what is the next step, since the Rayleigh equation looks like this. So the next step is to plot another graph. Okay, so let's say you have done the stepping off stages at different xb, and you get different value of xb, and you can calculate what is xd 1 over xd minus xb. So you must have 0.74, and let's say you have 0.66 and 0.6. Then you get what is the value of xb here, what is the value of xb here, what is the value of xb here. Should be 0.03 or close to that. Then you can calculate what are the values here, here, here. Okay, it's just 1 over this minus this. So what you do is, because you want to integrate, because Rayleigh equation says like this, okay, so you want to have this one is xb, and the y-axis is 1 over xd minus xb. So xb, the range for xb is the most you have is 0.2, okay, because this is your xb initial, and the least you have is 0.03 because this is your xb final. So you don't have to do from 0 to 1. Okay, so you have 0.03, then you can plot the graph. Okay, so when you plot the graph, next is you can calculate the area under the graph. So you can calculate the area under the graph. Here must be 0.03. Here is xb at xd equal to 0.74. Here is the xb at xd equals to 0.66. So you calculate the area under the graph. Okay, using whatever rule you want, trapezoidal rule or anything. then this area under the graph will give you L1 over L2. I mean the ln of L1 over L2 equals to area under the graph. Then from this you can find what is L2. Alright, so when you find L2, you can find D. D equals to L1 minus L2. Okay, half of part A is solved, and after you got the D, you can calculate the XD average using the material balance. So L1 XB1 equals to L2 XB2 plus L1 minus L2 XD average. Okay, such a long way to go. So from here you know L1 XB1, L2 XB2, this one of course you know, then you can find this. So that's the strategy, but you haven't really gotten into the ways of doing it. Okay? Alright, so from the VLE of ethanol water, you can plot the VLE diagram, and if you plot on Excel, it looks something like this. So you can do the first ROL, so yn plus 1 equal to 3 over 4 xn plus 1 over 4 xd. So this xd will change from 0.74 to 0.6. So let's start with when xd is 0.74. So you have yn plus 1 equals to 3 over 4 xn plus 0.185. So you find the ROL, so you start with the point xd 0.74, 0.7, 0.71, 72, 73, 74 here, okay, somewhere here, and then you can drag it down to 0.185, then draw a line. Sorry if my line is not really straight, but I'm trying to just give you a solution guide and idea on how to do it. So let's say this is your ROL. So this is your ROL when XD is equal to 0.74. So you step off 4 equilibrium stages because you're given in the question that you have 4 equilibrium stages. 1, 2, 3, 4. I mean, this is not correct because obviously you started with 0.2, so you have to have somewhere less than 0.2. Initially when I do it on paper, I got 0.19 as my XP. Okay, so let's assume I get the same with what I did on when I'm using paper. Okay, so when XD equals to 0.74, then XB I get 0.19. You might get different values, but whatever you get, that's your answer. Okay, it's not about right or wrong, but it's more about the method. So from here you can calculate what is 1 over XD minus XB. Okay, right, from here 1 over XD minus XB is 1.818181. Okay, let's just stop there. Then you repeat the same process for 0.66. Okay, let's say this time when xd is 0.66, your yn plus 1 equals to 3 over 4 xn plus 0.66 over 4. Okay, so but it should have the same gradient with the previous graph because your r is constant, so you have constant gradient. So what you do is you just take some point xd 0.6, so somewhere here. Okay, this is 0.6, and then you draw a parallel line to that point. So just imagine it's a parallel line. So this is your ROL when XD is 0.66. So you know the drill. Now you plot another, you step off stages. 1, 2, 3, 4. When I do it in paper, I got it 0.04. So I'm gonna just take that answer 0.04 and calculate the value. So the value is 1.613, and finally I do it at xd equals to 0.6. If I want to do it, I can. So I'm just going to show you. So 0.6, this is your ROL. Just draw a parallel line with the same gradient passing through 0.6, 0.6. Okay, so this would be your ROL when xd equals to 0.6. So if you really step off the stages on paper, hopefully you will get the same 0.03. Okay, 0.03. So the answer, I mean the 1 over xd minus xb here would be 1.68. Okay, so now you have this value. So what you do is you plot this graph, just this versus this, so that you can do the integration. So let's say you already have the xd, xb and 1 over xd minus xb tabulated as shown in this table here. Okay, just to highlight that I made a mistake in calculating this part in the previous slide. So the value is actually this one. When I checked using Excel, then only I realized. So from these values, I can plot the graph. So the y-axis is 1 over xd minus xb, and the x-axis is just xb. So from here, you can calculate the area under the graph. So it's just a simple calculation. No need to use your numerical method lessons. Okay, so I just divide this area into two parts. You can divide into more parts if you want to be more accurate. Just to show you as a guide, this is sufficient. So let's say I have this area A1 and area A2. So I'm just going to use the trapezium rule to calculate the areas. So area for A1 is just 1 over 2. If you can recall, what is the area or the formula for area of a trapezium? So 1 over 2 A plus B times the height. So in this case, this is part A, this is part B, and the height is this width. So just refer to this table to get the values of A and B and the height. So area of A1 is 1 over 2 times A is 1.754 if you want, plus B is 1.613 times the height. The height is the difference between these two values, so it's just 0.04 minus 0.03. Then you can calculate this and you get the area A1. Okay, you can check my answers if it's correct. Is it 0.0168? And then for area A2, you can do the same too. So this time the A plus B times H is then 1.613 plus 1.818 times 0.19 minus 0.04. So you can crunch the numbers and you get area A2 equals to 0.257. So the total area is A1 plus A2 equal to 0.2738. So going back to your Rayleigh equation, ln L1 over L2 equal to the area under the graph is 0.2738. Then L1 over L2 equals to the exponential of that, which is 1.315. So 100 is L1 over L2 equals to 1.315. So L2 is 76.05. So your D is L1 minus L2 equals to 100 minus 76.05. That will give you 23.95 pound moles. And then you can use the material balance equation to get the XD average. L1 XB1 equals to L2 XB2 plus D times XD average. So L1 is 100 times XD1 is 0.2 equals to 76.05 times XB2 is 0.03 plus D is 23.95 times XD average. Then you get XD average, the value. So the value of XD average is 0.7398 or equal to 0.74, which is almost the same with the initial composition of the distillate collected. Alright, so finish part A. Alright, so for part B, what would happen to the amount of distillate and the average composition of the distillate if you were to stop the distillation when XB reaches 0.06, okay? Because previously you started with 0.2 as the initial concentration in XB and you stopped when XB equals to 0.03. But now the question asks, what is D and what is XD average if you were to stop your distillation at XB equals to 0.06. So this is a bit tricky because it requires a trial and error. So you started with let us say XD 0.74 and then at constant reflux ratio R equals to 3, you get XB about 0.19, some get 0.185 and so on. It doesn't matter as long as you get your own values. Okay, so when you do 0.66 you get 0.04 as the XB, and when XD is 0.6 you get XB equals to 0.03. So the question asks, what if you stop the distillation when XB is 0.06? What would then be your XD? So, well, you have to do trial and error. So you put XB is equal to 0.06 here. Okay, so this is your final XD, and then you started with 0.74 just now, where you have the ROL. So what you have to do now is to draw a new ROL, guessing what is the value of XD, such that when you step off 4 stages, you get XB equals to 0.6. So now your calculation only stops from 0.19 to 0.06 when you want to do the integration or the area under the graph. Okay, so instead of going all the way from here, you stop here. So maybe you have to find another point where XB is between 0.19 and 0.06, where maybe 0.10. Okay, you have to find another XB here. So as long as you have 3 points, you can get what is XD here, what is XD here, then what is XB here. Then you can do the same step, draw a graph of XB. This is 1 over XD minus XB, and then get the area under the graph, and then get the new value of D, get the new value of XD average. I'm not going to go through this step again. I'm just suggesting what would be the strategy if you were asked what would you get for the value of t and the value of xt average if you were to stop the distillation when xb reaches 0.06 only? Right, so have fun, try to do this on your own, and if you want you can share your answers with me and with your friends. Okay, thank you.